First of all, thank you, everyone, for sticking around to the last session of the last day at the CAAs. I appreciate it. This is my first CAAs. It's been a wonderful experience. I hope to be here again, maybe next year. I don't know. We'll see. But this is the second paper I'm presenting here at this conference, but they're very much tied to each other in the way they're structured, these ideas, the way we capture data, and the way we distribute data to the public. This particular project, I've noticed a lot of papers given at the CAAs this year concerning digitization of places, buildings, large excavations. What we do a lot of is the digitization of the things that come from these places. So the artifacts, the material goods, these things that people do a lot of analytical processes on. So that's what I'm going to talk about today. First of all, a lot of artifacts that we take out of archaeological sites after they're processed and cataloged and then put back into boxes, they're stored, and a lot of times they don't really see the light of day after this initial process. They're either shoved in the back room of a museum, or they're distributed back to the owning peoples that maybe the lands these came from, or they're repatriated, they're reburied. So we don't really get to see these things again. This has become a concern not just for myself, but for a lot of archaeologists. And now that we live in a digital age, we have the ability to capture these objects before they disappear, essentially. And once they disappear, they become unknown to a lot of researchers. These things aren't visible in the light. A lot of people doing analyses on similar objects may not even know these things exist, and they may not know how to get access to them. So that's one of the reasons why we're doing what we're doing. Another reason is some artifacts are so incredibly fragile or rare or just incredibly unique that handling them is discouraged. So creating some kind of digital analog or digital surrogate for this object is incredibly useful for a lot of people. And for museums too, because then they can take these objects and they can display them. They can do other things with them without actually harming the object itself. And then, like I said, these collections are often dispersed after they're collected. They're returned to their owning parties. And we believe, my director, Dr. Maschner, and I have this mindset that, and it's not necessarily a mindset. It's an obligation that we have to produce these data and these objects and give them out to the world, because this is our past, our material past, and it's up to us to return these things to the people that are living today, to not only just do analyses on them, but to just look at them. I mean, there are kids across the world that love to look at cool artifacts. I know I grew up doing the same thing, but and this brings me to the project that I'm going to present to you today. It's called the Lower Alaska Peninsula Project, which is part of a greater project and idea. But what we're doing is we're taking thousands of artifacts from the Lower Alaska Peninsula, from dozens and dozens of excavations across almost 100 years of excavating in the Alaskan Peninsula, and digitizing these collections, both in 2 dimensions and 3 dimensions. So our goal is to digitize them, right? To capture these things in photographs and in 3 dimensions. So using laser scanners. We don't digitize absolutely everything. You can understand that looking through 5,000 retouched flakes or just debitage might be a little monotonous. A lot of people probably don't really want to analyze that after the first analysis, right? So we're digitizing, 3D digitizing a lot of these very diagnostic elements, these complete points, let's say. And we put these up online, and we want to get this digitized before these collections that we currently house at Idaho State University. We have all of these collections in one place, which is really kind of unique. And we want to digitize them before we give them back, because this is the last time all of these collections are going to be a single collection physically. So we want to kind of maintain that physical collection digitally. So that's one of our main goals. But everything we get to be a picture of, at least 2 pictures of everything. So you can imagine if we're talking about thousands of artifacts, we're talking about tens of thousands of pictures, right? And we want to take all of this data that we produce and we want to make a comprehensive, searchable, and analytical database. We don't just want to create a data storage, just a place to dump all the data and keep it there for people to come in and request access to. We want something to be visual. We want it to be people go to the website and instantly they see these things. We don't want to have people having to search and require access and do all these other steps that a lot of these collections require, both physically and digitally. So we want to make it visible. We also want to make this database searchable through multiple factors. So we want people to come in and say, I only want to see artifacts that are 2,000 years old or later, that are made of basalt, and then come from this area. We want to be able to give them an nth number of searchable items that they are interested in. So we don't want to have to make them wade through a lot of stuff that maybe they're not interested in to doing research on. They can get right to what their interests are. We want to make it readily available, and then we also want it to make it free, right? We don't want to have to force people to pay for this kind of thing. And that obviously raises other issues that we'll get to in a little bit. Now, establishing protocols for doing something like this, you can imagine is probably incredibly important, right? How do we go about doing this? Not just creating the database, but first of all, how do we go about digitizing the objects? We have to establish protocols so we can develop a pipeline, in sense, of doing this process. We've already established a rigorous set of protocols in using the virtual zoo archaeology of the Arctic project. That was my previous paper. I discussed part of that project. So we have established protocols in place for digitizing these objects, recording these objects digitally, getting all of the records, the physical records that we have associated with those objects, and putting them online in a database. So we already have an online database set up as well. So we've kind of already crossed several hurdles with that. Our data collection, so to get to the beginning of our pipeline, obviously we'll assume that we already have all the collections, which we do. Our data collection process, we always take two-dimensional images first. We use shadow-free imaging in an orderly light box. This is because we texture all of our models. We photo texture. We don't use color texture that comes off of let's say a Minolta Vivid 9i. We photo texture these objects because we get better resolution. We get more colored data. It's more accurate. So we always photograph these things, but then these photographs are also used in an archive sense, right? They're also used to help us search for these objects on our website. The second step is to digitize these objects in 3 dimensions. We use 2 main scanners for this, like I just said, the Minolta Vivid 9i, and then the Faro Edge Arm. The Edge Arm is our workhorse. It captures higher resolution. It's faster, but the nice thing about the Vivid is that it captures good enough resolution for things that don't have a lot of topology, right? They're perfect for that. And they have a turntable. You put them on the turntable, you press a button, and you walk away for 5 minutes so you can scan with the other arm. So we've kind of developed a way to really, really crank through a lot of material, which is good because we have a lot of material to go through. And then all of our records associated with these objects we have on hand, right? So site forms where these objects came from. We have any other kind of catalogs that are associated with these objects. And these catalogs I'll talk about in a little bit when I talk about reconciling data. And all of these other things we pull together and we put in this database. Now this database is structured, here's a nice video, is it playing? Yeah, it is. Of one of my colleagues using the Faro Edge Arm. I don't know if any of you have used this. It captures incredibly fast at really quite high resolution. We capture most of our artifacts. Obviously, he's not scanning an artifact, right? He's scanning a bison cranium. But we capture most of our artifacts at 0.1 millimeter resolution. So really quite good resolution for a lot of these things. and it's a phenomenal resolution for doing any kind of analytical analysis on, right? Don't need to see that anymore. So our database side of things. So we have a multi-tiered database where we have a front end, obviously, where we have the user, that's the user interface, where the people see the pretty pictures, they see the objects, they can do analytical analyses on them. Then we have the back end of the database where all of our data is stored. This database is designed to include all of the data that we have for these objects, but it is selective in what it displays to the observer on the front end, right? So certain things they won't be able to access. If they need to access it, they have to contact us and request access, like you would normally have to with a collection. But you can see on the right there a hierarchy tree. We're designing this to be a multiple tree system where you can search, like I said earlier, by multiple things, whatever you're interested in. Currently, we're building that. Right now, we have several things that you can search by effectively: place, material type, tool type. So if it's let's say a harpoon or hunting technology, things like that. But we're designing it to be plastic. We're designing it so that not just Alaskan archaeology can be included. We're designing it that so anything can be included, and any kind of data, any kind of 2D model or 2D image or 3D model can be included in this. We're designing this database so that it's flexible to the point that absolutely anything and everything can be added to it. Here's some more images of the database entry side. Once you put something in, it doesn't mean it's in and you can't change it. Everything can be changed. We collect data, all the data that we can on these objects. Anything that is included in catalogs for these artifacts, whatever, right? Whatever kind of data, metadata we have to go with these objects. We also show what kind of files we associate with each object. You can see on the right there, we have the 2D images that are uploaded, the 3D model, which is down on the bottom, and then the different texture files. Let's say we have a texture file, we have a normal map, and any other kind of 3D file associated with it. So the front end, when somebody comes into this website, they see something similar to this. And obviously this is growing continuously. They'll see an object that's associated with a site. We can change this for it to be maybe a picture of a site. So these things right now, as you pull them up, are listed by sites, whether or not they have a site name, but most sites have a site number, right? Once you click on a site, you can see there on the left, you have artifact types there, and you see little blue checks. You can go through and you can select or deselect certain kinds of artifact types, and then it will automatically take them away or add them to the database for that particular site. When you found an object that you're interested on, you can highlight it and it can tell you more about that object. The nice thing about these 2D images is we have an active zoom 2D image system where you can continuously zoom in on the object to the full resolution of your monitor. So you don't have to click on an image and pull up in a separate tab. You're constantly zooming in and out on the same page. There's no back and forth. You can see this is zooming in. You can see flake scars. So you can do on-screen just visual analytics, right? You can look at these things live on screen. Our 3D models, our 3D model viewer, we display several different kinds of data that we include in all of our 3D models. So we have a fully textured model, like the one seen here. We have a normal map, which is detail added back into the object from the 2D image, and then we also show a mesh. Obviously, these objects are in significantly lower resolution than what we actually capture, but the idea is if we can capture these things at the highest resolution that we can or that's possible, then in the future, when things catch up to this technology, when the software does catch up to this technology, this hardware, then we can display it. So the data is there. We store the raw data as well in the back end of our database. Another thing about our viewers, we can pull in multiple models at one time. We can analyze things at the same time. If we have a series of, that object on the left is a little figurine from Alaska. Let's say we pull up multiple figurines and we want to see them all together, compare them side by side to look at that shape, size, etc. They're automatically scaled to each other as soon as you pull it in. And I think we can pull in 6 models right now, but we're increasing that as we speak. One of the strong points for this database, in my opinion, is that it's an analytical tool. It's not, like I said earlier, it's not just a drag and drop, dump your data here and we'll store it for you. This is a database that acts as a tool itself to do metrics and to export those metrics. Our on-screen measurement tool for both 2D and 3D is in-house built metric tool. You calibrate the metric, the scale to the pixel sizes on your screen. It's very easy to do. And then you can do length measurements, you can do width measurements, angle measurements, pretty much anything like that. And you can export these things directly into an Excel spreadsheet. So if you want to do research on anything that we have on this database, you're welcome to. The images and the 3D models are there for you to be able to do that. That's one of our goals, is for if anybody wants to do these kinds of things, they can. They don't have to travel. They don't have to ask permission. They don't have to have all of these special circumstances fall in line for them. They can just do it. One interesting thing about this analytical tool is I've been running an ongoing test on these metrics to see how accurate they are. And I didn't put any of this data up, and I'm not sure why I didn't, but I will briefly talk about it. I found that the error inherent in metrics, and if any of you have done any kind of metric analysis, you know that there is some level of inter and intra-observer error that is acceptable, correct? And I've been trying to find out how accurate these on-screen metrics are as far as repeatability is concerned, and also compared to hand measurements. And I've found that, like any other metric tool, let's say sliding calipers, if you're not familiar with the tool, it's going to take you a while to get used to it. And I found that my error fluctuated, and then after about 10 tries, it leveled off. So what I was noticing is a fluctuation in my ability to use the tool. I was getting used to the tool. As soon as I got used to the tool, my metrics became level. They became very, very small, the error. Another beautiful thing about these tools is that angle measurements become significantly more finite and significantly more accurate. Rather than measuring an angle to the nearest degree or a tenth of a degree, we're talking about hundredths of a degree. So we're getting much finer detail on these metrics. And this is probably my favorite part of this database is being able to do these mathematical analytical processes on these things. Of course, I love measuring things. I always have. And then we get to this idea of reconciliation. And what I mean by this is that we have decades and decades of archaeological material that has all been excavated slightly differently. Our records are different. Everything is cataloged slightly different. Everything has had a different method behind it of acquisition. How do we put all of these things that are different into a single database that communicates with everything? How do we do this? This has been one of the biggest challenges for us, and we've found that a lot of times after we process and capture these images in 3D, those objects actually help us reconcile either missing data, duplicate data, things like that. We're still working on the best way to make some of these things mesh, really. We get a lot of sites that were excavated, like the Hot Springs site was excavated multiple times over 80 years. And we have the same site, but we have separate excavations on the same site. So we have the same site, but we have, let's say, 50 catalog numbers that have a catalog number of 1. How do we control that? We're still working on this, but right now, as I showed you on the database, we're not organizing it by catalog number, right? We're organizing it by other means, normally location, which obviously if you're just organizing it by site, that comes into that still plays a part in our reconciliation. So we're still working on the best way to control these discrepancies. But we found that when we find duplicate data, these 3D objects and 2D objects help us solve the problem. They help us decide who or which object is the correct object for that correct catalog number. And we found it to be incredibly helpful. So what makes us different? Well, like I've already talked about, rather than just a database, a place to put data and store it, and for people to go and access it in some way, we make it visual. We want people to see these things like they would be able to if they walked into a museum. We also want them to be able to handle them in a sense of being able to do metrics on them or any kind of analytical analysis. That's kind of what makes us different. A lot of times I've had people contact me about, well, how is this different from TDAR? And if you're not familiar with TDAR, TDAR is the digital archaeological record. It's at Arizona State University, I think. They are a trusted data repository for archaeological materials. They store the data. They're like a data housing, but they require certain things of the data in order for it to be stored. Things that we record, right? That we're very interested in, a lot of the metadata. But one of the problems is that when you're dealing with tens of thousands of images and thousands of 3D models, you're talking about terabytes of data. When you have to store terabytes of data on a database that requires a fee for megabytes or gigabytes, you're talking about a lot of money. Financially, some things don't work out the way that you would want them to. And this is one of the reasons why TDAR hasn't worked for us, just because of the massive amount of data that we have, that we've produced. And so that just brings me to my last point of what makes us different is that we're free. We're not charging to include objects into this. We're not charging for people to access this. We want this to be free because we figure that my paycheck comes from National Science Foundation grants. So the people of the United States have paid for me to do this already. So I can't charge them to access this material. This is their material. So this is one of the reasons why we do this. Long term, obviously, I think this has been asked in pretty much every paper that I've seen. What's the long-term goal? How do you fund this long-term? Well, that's a really good question. That's a question that I don't think anybody can answer unless they have a check sitting on their lap, right? So we are trying to find ways to continually fund this project and projects like it to make it almost an establishment, something that is that people are wanting to be involved with and wanting to invest in. And a lot of times these projects don't go beyond what the PI of the project either had originally intended, or they don't go beyond the PI of the project's life or their retirement, right? So a lot of times these projects depend on the person that started them to maintain them. And we're working on ways to move beyond that. And I think by displaying what we can do and the kind of tools that we can produce, we're enabling ourselves to be more, not just visible to the public, but visible to people that want to invest in this kind of thing, whether it's the government or private institutions or anything like that. Currently, we have over 12,000 artifacts photographed. That's at least 2 artifacts per photograph, or per, 2 photographs per artifact. Sorry, I flipped that around. We still have quite a bit more to go. We have over 3,000 artifacts scanned. Now, we don't have over 3,000 artifacts built, right? We can scan them a lot faster than we can build them. We can create the 3D model. But we are working as fast and as hard as we can on this. The following stages beyond completing the material that we have in-house is to include more material from, let's say, Alaska or the Arctic, or material from anywhere, Italy, right? We can put Italian archaeology into this database. It's not specific to the Alaskan archaeology. Even though Alaskan is in the name, it doesn't mean that it will segregate out those non-Alaskan artifacts. And then, like I said, I already talked about funding. And on that note, I want to thank all of my co-authors and all of the contributing parties to this project and other projects that I've been involved on. I want to thank all of you for sticking around for this last session.